when you look at a flip-flop, you know if it's going to work on the leading edge or the trailing edge, on the rising edge or the falling edge. When you see a bubble like this one, when you see a bubble on this one like this one, that works on the trailing edge, the falling edge. What does that mean? As the clock goes from high to low. This one, there's no bubble. That works on the leading edge as the clock goes from low to high. That's when we look at them. So when we in the lab on Thursday start looking at these, pay attention to them to see if they work on the leading edge or the falling edge. Now the other thing is all these flip-flop also have a couple of extra buttons on them. One is known as set and reset, to clear and preset. So this one works on the falling edge. Notice the clock, there's a bubble with it. So as the clock goes from high to low. Now initially we said you can have Q to be either 0 or 1. If you hit the clear, notice in this case the clear has to be 0. If you put a 0 here, that will clear that one. That will make that one a 0. Which means this is a 1. That's the complement of this. If you hit the preset, you put a 0 on this for this one, that's preset. It's going to make Q equals to 1 initially, and this will be 0. So you can have the initial value, as I said before, could be 0 or 1 based on what you attach to these two. If you want it to be 0, you ground this one, and you make that one high. If you want to actually make it a 1, you ground this one the way it's designed, because there's a bubble here. You ground that one, and you make this one high. So it's going to make it a 1. So we can have it any value we want it. Notice if the preset value is 0, if you make that one 0, it doesn't matter what the clear, or if the clear is 1, it doesn't matter what the D and X is. If you make this one 0 and this one 1, it's going to make it Q equals to 1. On the other hand, if you make this one 1 and this is 0, you reset it, you make that one 0. If you want it to work the right way, not affect them, you make them both high, then it's based on the value of D. Once they're both high, neither one of these is a factor. Everything depends on D and the clock.
You mean low?
If you make them high, not low, because I don't want to use them. Once you make them 0, you actually force them to do something. Once you make them 1 in this case, they don't do anything. See the bubble on them, Ravi? Yeah. So that's how these work. So if they're both high, so this is not a factor, that's not a factor. But once you make one of them 0, you can't make them both 0 at the same time. That's a no-no. Why? Because you tell them, make it 0, make it 1 at the same time. How can you be 0 and 1 at the same time? You can't be. So if you make this one 0 and that's 1, that's clear, you make it 0. If you make 0 and 1, that's preset, you make that a 1. You don't want them to be any factor, you make them both 1s. Now we have other flip-flops on the market. And again, there's a timing diagram and there's a little delays. Notice how we're showing you the delay. It takes a few seconds for it to go from 0 to 1 or 1 to 0. It never happens that quickly. There's always that little charge time. We're trying to show you these delays here. See them? I don't know if you can see them. There's a little dotted line. Yeah, you can see it. I can see the dotted line. So this is actually when the clock goes from 1 to 0, but nothing happens for a few milliseconds, microseconds before it takes effect because of the delays of the gates. So we're going to be looking at SR flip-flop, a JK flip-flop, a T flip-flop. We have lots of flip-flops. A master-slave flip-flop. Then we'll start working with them, designing them. So last time we only got a chance to look at D flip-flop, right? And again, D flip-flop is called data flip-flop. Yeah, I gotta keep it like this because I'm trying to show the whole picture there. Big enough. D flip-flop I'm not paying attention to the clock here. I have an input, one input D and two outputs, Q and Q naught. And basically the next state, so this is D, This is the current state, Q, and this is Q asterisk. If D is 0 and this is 0, you end up with 0. 0, 1, you end up with 0. 1, 0, you end up with 1. 1, 1, you end up with 1. That's what the truth table for the D flip-flop from last class. And what do you notice? It looks like Q follows what? The next state is always what D is. It doesn't matter what the previous state is. So basically, if you want to summarize the truth table in a different way, when D is 0, you get a 0. When D is 1, you get a 1. As simple as that. Now, we have other flip-flops. We have JK flip-flop, SR flip-flop. So let me talk about the SR flip-flop. My hand up there on the top. It's going to be interesting today.
Why is a D flip-flop called a data flip?
Because it follows the data. It follows what D is. When D is 0, you get a 0. When D is 1, you get a 1. It doesn't matter what the current state is, really. As long as D is 0, you're going to have a 0. When D is 1, regardless what the current state is, it doesn't affect it.
Now, are there signals going through D, or is it just a high and low?
What do you mean singles?
Like, is there a signal going?
A signal, I'm sorry. Signal, yeah, it's either going to be a 0 or a high voltage. You know, 0 or 5, VCC or ground. Yeah. Now, we have other flip-flop that they don't follow just the data. For example, we have one called SR flip-flop. And this is the next state. And the way the SR is, if both, by the way, the reason they call this SR stands for set, reset flip-flop. But instead of reset, we call them SR flip-flop. That's where the name came from. If both inputs are 0, the next state will be the same as the previous state. Whatever the previous state used to be stays the same. So no change. If it's 0, 1, 1 is reset. The next state is always going to be a 0. If it's 1, 0, the next state is going to be always a set, which is a 1. And for this SR flip-flop, 1 and 1 is not allowed. You do not want to put 1 and 1 on it. The reason you don't want to put 1 and 1, when you look at that flip-flop, again, I'm not showing you the clock and the preset and the clear, which we have them all. Bless you. We have two inputs, S and R, and we have two outputs, Q and Q naught. When you make it 0, 0, this state will be whatever the previous one. 0, 1, R is 1, this will be a 0. 1, 0, that'll be a 1. When you make it 1 and 1, here's the problem with them. These guys are supposed to be the complement of each other. When you put 1 and 1, they're not the complement. You end up with the same output. And we don't want to have, because it's supposed to be Q and Q naught. How can you have 1 and 1 here if the other one is the complement of this one? That's why you're not allowed to put 1 and 1 to that one. We have a very similar one to this. It's almost the same one that you can put 1 and 1. But that's called, instead of SR, we call it JK flip-flop. So a JK flip-flop is just like this one. And I got all these I think I have them all in the lab. JK flip-flop, just like the SR. If you put 0, 0, the next state stays the same. If you put 0, 1, this is SR basically, you know? SR, that's a reset. If you put 1, 0, that's a set. And there's the difference. If you put 1 and 1 with SR, you're not allowed to have that. With the JK flip-flop, it says no problem, you can have that. And the result will be the complement of the previous state. The complement. That's called JK flip-flop. I don't know what it stands for, actually, to be honest with you. Yeah, this one. I think they're just similar to SR. We use the SR. So someone says, oh, let's call it, I don't know. I would have called it ZH flip-flop. My initials. But I don't think it stands for anything. The JK, SR stands for set, reset. The D stands for data. The JK, I don't know. And we also have another one. It's called a T flip-flop. I'll do timing diagram shortly. Going to be a mess today with these notes. Half a page. A T flip-flop, here's the truth table for it. Q next. When T is 0, you end up with Q. When T is 1, you end up with Q naught. Why they call it T flip-flop? Toggle. When T is 1, it flips, it toggles. So that's where the name came from for T flip-flop. I'm going to do some timing diagram, but I got to stop the camera and redo the sides because it's bugging me. Everything is all over, you know, so big there.